NCERT में आज हम लोग रियल नंबर्स पढ़ेंगे। एनी नंबर डैट वी कैन थिंक ऑफ एक्सेप्ट कॉम्प्लेक्स नंबर इज कॉल्ड ए रियल नंबर। फॉर एग्जाम्पल 3, 0, 1.5, 3/2, √5 एंड सो ऑन। हम लोग थोड़ा कॉम्प्लेक्स नंबर देख लेते हैं। नंबर अदर देन रियल नंबर और ए नंबर विच कैन नॉट बी रिप्रेजेंटेड ऑन नंबर लाइन। एग्जाम्पल 5 + 3i 2i where I equal to √-1। प्रॉपर्टीज ऑफ रियल नंबर्स। पहला क्लोजर प्रॉपर्टी देखेंगे। द क्लोजर प्रॉपर्टी ऑफ रियल नंबर स्टेट दैट इफ a and b belongs to real number, a plus b and ab also belong to real number. Real number into real number equal to real number plus real number that is equal to real number. अगला प्रॉपर्टी एसोसिएटिव प्रॉपर्टी पढ़ते हैं। द सम और प्रोडक्ट ऑफ एनी थ्री रियल नंबर्स रिमेन द सेम even when the grouping of the numbers is changed. A plus b plus c in bracket that is equal to a plus b in bracket plus c where a, b, c belong to real number, a into b into c in bracket that is equal to a into b into c where a, b, c belongs to real number. Commutative property, the sum and the product of two real numbers remain the same even after interchanging the order of numbers. A plus b equal to b plus a where ab belong to real number, a into b equal to b into a where ab belong to real number. Next property distributive property है। The distributive property of multiplication over addition that is equal to a into b plus c in bracket that can be written as a into b in bracket plus a into c in bracket where a, b, c belong to real number. The distributive property of multiplication over subtraction that can be written as a into b minus c in bracket that is equal to a into b in bracket minus a into c in bracket where a, b, c belong to real number. Sets of real number represented by symbol r. Sets of real number is union of rational and irrational number. Real number equal to q union q dot where q is a symbol of rational number and q dot is a symbol of irrational number. आगे हम लोग पढ़ेंगे रियल नंबर्स ऑन द नंबर लाइन। स्टेप 1, ड्रॉ अ हॉरिजॉन्टल लाइन विथ एरो ऑन बोथ एंड एंड मार्क द नंबर 0 इन द मिडिल। द नंबर 0 इज कॉल्ड द ओरिजिन। स्टेप 2, मार्क द इक्वल लेंथ ऑन बोथ साइड्स ऑफ द ओरिजिन एंड लेबल इट विथ ए डेफिनिट स्केल। स्टेप 3, it should be noted that the positive numbers lies on the right side of the origin and the negative numbers lies on the left side of the origin. Factorization of numbers, हम लोग इसे देखते हैं। A factor is a smallest number that divide the given number without any remainder. The factorization formula of a given value can be expressed as n equal to x to the power a into y to the power b into z to the power c where n equal to any number x, y, z a factor of numbers and a, b, c exponent of factors x, y, z respectively. Example के लिए what the prime factorization of 40, the use factorization formula of any number n equal to x to the power a into y to the power b into z to the power c, 40 equal to 2 to the power 3 into 5. Example के लिए if the factorization of a number is 2 to the power 2 into 3 to the power 2 into 5. Find the number by using the factorization formula. The factorization formula of a given expression is n equal to x to the power a into y to the power b into z to the power c where n is any number x equal to 2, y equal to 3 and z equal to 5. Prime factors of number n, a equal to 2, b equal to 2 and c equal to 1, exponents of the factors x, y, z respectively. To put expression in formula, then you will get n equal to 2 to the power 2 into 3 to the power 2 into 5 that is equal to 4 into 9 into 5 that is equal to 180. Note, prime number. A prime number is a number that can only be divided by itself and 1 without रिमाइंडर्स। एग्जाम्पल के लिए हम लोग देखते हैं 2, 3, 5, 7, 11 etc. यूक्लिड्स डिवीजन algorithm, it is a technique to find the highest common factor HCF or greatest common divisor GCD of two positive integers a and b. Euclid division lemma, it can be represented as a equal to bq plus r, such that a and b are two positive integers, q quotient and r remainders, and unique integers where r belongs to 0 to b. Step 1, apply the division method to a and b and find a equal to bq plus r. If remainder is 0, then HCF will be b. हम लोग स्टेप 2 देखेंगे. इफ आर नॉट इक्वल टू 0, अप्लाई डिवीजन फॉर्मूला अगेन टू बी एंड आर, that is equal to b equal to rq1 plus r1. Then step 3, repeat the process until the remainder become 0. The divisor is that step is the HCF. Example, HCF of 135 and 225, that is equal to solution, use Euclid's division algorithm. तो स्टेप 1, 225 is equal to 135 into 1 plus 90, where a equal to 225, b equal to 135 and q equal to 1 and remainder 90. Step 2, if r equal to 90, apply division formula again to b and r. 135, that is equal to 90 into 1 plus 45, where b equal to 135, q1 equal to 1, r1 equal to 45. Step 3, here r equal to 45, so again apply division formula to b1 and r1. 92 equal to 45 into 2 plus 0, where 45, q2 equal to 2, r2 equal to 0. Here r remainder is 0, so answer is 45. Now we will see theorem 1.1, Fundamental Theorem of Arithmetic. So it represents that every composite number can be factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occurs. तो सबसे पहले इसकी एग्जिस्टेंस की बात करते हैं. तो एनी इंटीजर n greater than 1 can be expressed as a product of primes p1 into p2 into p3 up to pk. Uniqueness, the factorization is a unique for any given number, meaning no two different sets of prime numbers can multiply to the same result. इसका रिप्रेजेंटेशन देखते हैं. तो कॉमनली एक्सप्रेस्ड एज n इक्वल टू p1 to the power a1 into p to the power a2 up to pk to the power ak, where pi distinct prime number, ai positive integers. Note, a composite number is a positive integer greater than 1 that has more than 2 factors. एग्जाम्पल के लिए हम लोग देखते हैं 4, 6, 8, 9 etc. Now we will see example of the theorem. The first example is 12. 12 is a composite number and it is greater than 1. So 12 can be written as 2 into 2 into 3 in a prime factorization. Here we see 2 and 3 is a prime number and 2 repeat itself. So we can write 12 equal to 2 to the power 2 into 3. Here we find that p1 equal to 2, p2 equal to 3 and a1 equal to 2 and a2 equal to 1. Now second 6936, it is also a composite number and greater than 1. So 3963 can be written as 2 into 2 into 2 into 3 into 3 into 17 into 17. That can be written as 2 to the power q into 3 square into 17 square. We will learn finding of LCM and HCF using prime factorization method. So to find the LCM and HCF of the given pair of integers, first find the prime factors of the given numbers, then identify common prime factors and select the smallest exponent या power for each to find HCF. Then again identify all prime factors and select the greatest exponent power for each to find LCM. हम लोग कुछ एग्जाम्पल देखते हैं. तो फर्स्ट फाइंड LCM एंड HCF ऑफ 12, 15 एंड 21. तो स्टेप 1 में फर्स्टली फाइंड प्राइम फैक्टर यूजिंग डिवीजन मेथड. तो हम लोग देखते हैं 12 को सबसे पहले 2 से डिवाइड करेंगे तो 6 आएगा. 6 को 2 से डिवाइड करेंगे तो 3 आएगा. 12 इक्वल टू 2 इंटू 2 इंटू 3, वेयर 2 and 3 इज ए प्राइम नंबर. नेक्स्ट 15 है, 15 को 3 से डिवाइड करेंगे तो 5 आएगा। 15 इक्वल टू 3 इंटू 5 वेयर 3 एंड 5 इज ए प्राइम नंबर। 21 को 3 से डिवाइड करेंगे तो 7 आएगा। 21 इक्वल टू 3 इंटू 7 वेयर 3 एंड 7 इज प्राइम नंबर। नाउ स्टेप 2, 12 इक्वल टू 2 स्क्वायर इंटू 3, 15 इक्वल टू 3 इंटू 5, 21 इक्वल टू 3 इंटू 7। स्टेप 3, LCM of 12, 15, 25, that is maximum power of 2 equal to 2, maximum power of 3 is 1, maximum power of 5 is 1, maximum power of 7 is 1. Now 2 square into 5 के power 1 into 3 to the power 1 into 7 to the power 1, that is equal to 420. Now we will find HCF of 12, 15, 25. Then common factor is 3 in 12, 15, 25. Minimum power of 3 is 1, so 3 to the power 1 equal to 3. Now we see next example. Find LCM and HCF of 8, 9, 25. Step 1. Firstly find the prime factor using division method. So 8 divided by 2, that is 4. 4 divided by 2, that is equal to 2. Then 8 equal to 2 into 2 into 2, where 2 is a prime number. Now 25 divided by 5, that is 5. 25 equal to 5 into 5, where 5 is a prime number. Now 9 divided by 3, that is equal to 3. 9 equal to 3 into 3, where 3 is a prime number. No common factor in 8, 25, 9. So HCF is 1. LCM equal to 2 to the power q into 5 square into 3 square, that will be 1800. Now we will learn formula verification for two numbers a and b. HCF of a and b into LCM of a and b, that is equal to product of number a and b. Now some example. Find the HCF of 96 and 404 by prime factorization method, hence find their LCM. Now solution. Prime factorization of 96 and 404. तो prime factorization of 96, that is equal to 2 to the power 5 into 3, and same for 404, that is equal to 2 square into 101. Now HCF common integer between 96 and 4 and 4 is 2 square, that is 4. HCF 96, 404 into LCM of 96, 4 and 4 equal to product of number 96 into 404, then 4 into LCM, that is equal to 96 into 404. Now simplify it. After simplification you will get 101 into 96, that equal to 9696. Now we will see another example. Find the LCM and HCF of 6, 72 and 120 by prime factorization method. For this, firstly find prime factorization of 6, 72 and 120. Then we get 6 equal to 2 into 3, 72 equal to 2 to the power q into 3 square, 120 equal to 2 to the power q, 3 into 5. Now HCF common integers between 6, 72 and 120, that is 2 into 3, that is equal to 6. Now LCM of 6, 72 and 120, that is equal to 2 to the power q into 3 square into 5, that is equal to 360. Now according to verification formula, LCM of 6, 72 and 120 into HCF of 6, 72, 120, that is equal to product of numbers 6, 72, 120, and that can be written as 360 into 3, that is equal to 6 into 72 into 120, that will come 1080, not equal to 51840. The product of three numbers is not equal to the product of their HCF and LCM, so here verification formula not work in case of the three numbers. Now the product of three numbers PQR not equal to LCM of PQR into HCF of PQR. For three numbers we will learn to find LCM of PQR, that is equal to P into Q into R into HCF of PQR, that divided by HCF of PQ into HCF of QR into HCF of PR. Similarly, we will learn HCF of PQR, that is equal to P into Q into R into LCM of PQR divided by LCM of PQ into LCM of QR into LCM of PR. Now we see some examples. First, find LCM of 2, 3, 5 using formula. Then LCM of 2, 3, 5, that is equal to product of number P into Q into R into HCF PQR, that divided by HCF of PQ into HCF of QR into HCF of PR, that can be written as 2 into 3 into 5 into HCF of 2, 3 and 5 divided by HCF of 2 and 3 into HCF of 3 and 5 into HCF of 2 and 5. As we know, all are prime numbers, so HCF is 1, so 2 into 3 into 5 into 1 divided by 1 into 1 into 1, that is equal to 30. Now we will see another example. Find HCF of 235 using formula. Then HCF of 235, that is equal to P into Q into R into LCM of PQR divided by LCM of PQ into LCM of QR into LCM of PR, that will be 2 into 3 into 5 into LCM of 2 into 3 5, that divided by LCM of 2 3 into LCM of 3 5 into LCM of 2 5, that will be 2 into 3 into 5 into 30 divided by 6 into 15 into 10, that will be 900 divided by 900, that will be 1. Now we will see theorem 1.2. Let P be a prime number. If divides a square, then P divides a, where a is positive integers. इसका हम लोग प्रूफ देखेंगे. लेट द प्राइम फैक्टराइजेशन ऑफ ए दैट इज इक्वल टू P1 इंटू P2 इंटू P3 up to Pn, where P1, P2, P3, Pn are primes, not necessarily distinct. Therefore, we can write a square that is equal to P1 into P2 into P3 up to Pn into P1, P2, P3 into Pn, that can be written as P1 square, P2 square, P3 square up to Pn square. We are given that P divides a square. Therefore, by fundamental theorem of arithmetic, theorem 1.1, P is one of the prime factor of a square according to uniqueness part of fundamental theorem of arithmetic. Prime factor of a square is P1, P2, P3, Pn, and P is one of them. Now a equal to P1, P2, P3, Pn, P divides a square. Now we will see theorem 1.3, that is root m is a irrational number, and for this we will see proof. Let us assume root m is rational number. So root m can be expressed as P by Q, where P and Q are integers and Q not equal to 0, such that P and Q is prime, no common factor other than 1. Now root m that can be written as P by Q. Squaring both sides, we get m equal to P square by Q square. Now P square equal to Q square m. P square equal to mq square. That means P square is multiple of m, which means P is also a multiple of m. By theorem 1.2, let P equal to mc for some integer c. Mc square equal to Q square m. Substitute P equal to mc. Now Q square equal to mc square. After simplifying, this indicates that Q square is a multiple of m, meaning Q must also be multiple of m. Since both P and Q are divisible by m, they share a common factor of m. This contradicts the initial assumption that P and Q are co-prime. Now conclusion. The contradiction means the original assumption that root m is rational number is false. Therefore, root m is irrational. Thanks for watching video. Like, share and subscribe please.